so we have two equal sides of an isosceles triangle are each 24 centimeters. So when I say isosceles triangle, what do I mean?
Triangle that has no equal sides.
It has two equal sides.
Ms. Fuller should have emailed you.
I got it, thank you. Oh, also, okay, so these two equal sides are both 24. The two equal angles are each 52 degrees. Find the length of the base and the altitude. So the base is the bottom here. I'm going to call it B for base. What's an altitude? So if I drew in the height, I'm going to call that A for altitude. What kind of angle is formed?
Right angle.
An altitude always makes a right angle with the bottom. Okay. Our trig functions only work in right triangles, so I can't use any trig functions for the whole thing. But these two smaller ones are both right triangles, so I could use it for those. Because it's isosceles, one of those properties says that this altitude would actually cut the bottom in half. So we have two identical triangles here. Let's find the altitude first. So if we pick one of our triangles, I go for my 52. This is my opposite. 24 is the hypotenuse. What trig function? So I could say the sine of 52 degrees equals the opposite side A for the hypotenuse 24. So to solve it, we'll have to multiply the 24 over. Grab a calculator. Make sure you are in degree mode. And just for practice, we get 18.9123. How many significant digits did we have? 2. So we would call this 19. What would my unit be? All right. Now I have to find the base. The base is for the whole triangle. And I can't use my trig function in the whole thing. But if I take half of it, could I find this side x? And then what would I have to do with that to get the length of the base? Times it by 2. Okay, couple ways we can get this. We could do Pythagorean theorem at this point because we do have both of those sides. There will be some rounding error there because we did round our 19. We could also set up a trig function. So either option is okay as long as you are showing me the work. I told you when you use significant digits, it can throw off your answers. So you have to give me the work so I know how you got the answer you got. I'll just do a trig function to practice that. So from my 52, x is the adjacent, 24 is hypotenuse. What trig function?
Cosine.
So the cosine of 52 degrees equals the adjacent x of the hypotenuse 24. So multiply the 24. 14.7759, or we would round that to 15 centimeters for the significant digits. So then, the final base. What would that be?
30 centimeters.
We take it times 2, and we get 30 centimeters. Okay with everybody? Any questions there? Let's do, I'm gonna skip this one. I want to go to this one, I think. How long should an escalator be if it's to make an angle of 33 degrees with the floor and carry people a vertical distance of 21 feet between floors. So what's an escalator?
Basically a staircase.
Yeah, like moving stairs, right? So we know if we're drawing a triangle, the escalator is the slanted side, the hypotenuse. And then I could turn this into a right triangle. So we're trying to find how long the escalator is. So we're looking for this hypotenuse. The angle of 33 degrees with the floor. Where would that go? With the floor. Floor is down at the bottom. Carries people a vertical distance of 21 feet, so that side is 21. Alright. What trig function would we use? So the sine of 33 degrees equals the opposite side 21, or the hypotenuse x. To solve, we always have to multiply by what's on the bottom, which means then we have to divide by the sine. Divided by the sine of 33 degrees. How many significant digits?
2.
So we get 38.5576, so we round that to 39 feet. I'd like to do probably one more problem together and then give you guys some opportunities to work so you can ask questions. Let's do this. A man climbs 213 meters up the side of a pyramid. So how would I draw that? Do we know what a pyramid is? So let's draw one face of the pyramid. So we're looking at a triangle. If he goes up the side, then he's walking along this diagonal here so he can get to the top. So the 213 is this side. Then the angle of depression. How do you find an angle of depression?
Is the angle going?
Right. But remember when we do elevation and depression, we have to draw in a horizontal line. So he's up here. So I need a horizontal line up here with him. And it's from that line down. We get 52.6 degrees. How high off the ground is he? Right. There's a few different ways we could draw this. If we're trying to find how high off the ground he is, we're looking for this, x. Could you also draw it out here if you wanted? Those would be the same. So it's just a matter of, do you want to look at this little triangle or do you want to focus on this triangle out here? It doesn't matter a bit. This one is maybe saves us a step because we have an angle in that triangle, but you'll get it either way. So if I use that triangle that I highlighted there, what trig function are we doing?
Sine.
You can say the sine 52.6 degrees equals my opposite side x over my hypotenuse 213. Multiply that over. We needed 3 significant digits on this one.